Hi guys, in this video we are going to see a problem on binary search tree. Delete node in a BST. So let's see what we have given. We have given the root of BST and an integer value key. So we need to delete a node with value key from that tree, and we need to return the root of the answer binary search tree. So let's see what we can do. Let me copy this thing. Okay, so this is a binary search tree. If we want to delete 2 from this binary search tree, what we need to do, first we will find out that node which we want to delete. Find node which we need to delete, which we will delete. In any case, this thing we need to do. So let's say if we want to delete 2, then what we'll do, we will connect 4 with 5. This is the right pointer of 2. So if there exists any left pointer and right pointer is null, then we will attach this left pointer to 5, and there are four cases. First will be there exists only right one. Second will be there exists only left one. In third case, both are not present, both are null, both childs are null, and in fourth case both childs are present. So in these two cases, what we will do, we will simply return the node which is present. Let's say if only left is non-null, then we will return the left node from the function, and if only right is non-null, then we will return right from the function. In third case, if both are null, then we will return null from our function, and in fourth case, this is most complicated case, both childs are present. So let's say if we want to delete 5, then we can place this 2. Let me clear this thing. Okay, so let's say we want to delete 5, so we can place this 2 at the position of 5. We can place, but if this have 2 pointers, two childs, then we cannot do this. If we want to delete 5, there is only one way, which we will find minimum element in the right binary search tree, and we will find the maximum element in the left binary search tree. So the minimum element in right one is 6. So what we will do, we will replace this 5 with 6, and we will delete this 6 from here, and we will attach this 7 at here. So that will be an valid answer. And if we don't want to do this, then we will do we will find maximum element from the left one, and we will do same thing as we will replace this 5 with 4, and then we will delete 4 from left binary search tree. This thing we will see in our code at there. It will be more clear for you. So let's see its implementation. Okay, so in first case, if our root is null, we will directly return null. Okay, so now there are 3 possibilities. If root arrow value is greater than key, then what we will do, we will if it is greater than key, then key will present on left binary tree. So we will update our root arrow left, which is left binary tree, as a new binary tree in which key is not present. So delete node root arrow value, root arrow left, and we need to delete key, so key. That's it. Then we have second case, else if root arrow value equal to key. So this one is much larger than we think. So let's go for third case. Third case is root arrow value is less than key. So that will be covered in else statement. So what we'll do, root arrow right, will update right binary tree as delete node from root arrow right key, and at last what we will do, we will return root. Okay, so in second case, which is value is equal to key, means we have found that we have found the node which we want to delete. So in this string is this thing, we have three cases. Case 1, left, only left or only right is non-null. Only left or only right is non-null. So yeah, we will cover this thing. If root arrow left is not equal to null and root arrow right is null, what we'll do, we will return root arrow left. Okay, and if root arrow right is not null and root arrow left is null, we will return root arrow right. Okay, we have covered our first case. In second case, what is our second case? In second case, there exist both are null. Okay, second case is both are null. So case 2, both are null. if root arrow left is equal to null and root arrow right is equal to null, we will return null. Sorry, we will delete root. We will delete root, and then return null. We are forgetting to delete root from every part, so delete. No, right here we can't do that thing because root arrow left, which is a binary tree from left, is attached to root, so we can't delete root in these two cases. So let's go for third case. Third case is if case 3, if both are present, both nodes, both childs are non-null, then what we will do, we will check if root arrow left is not equal to null and root arrow right is not equal to null. And what we will do, in this case, what we need to do, we need to find out the minimum element from right and largest element from left. So I'll go for right one. So let's make a tree node temporary, which is initially equal to root arrow right. So if we want to find the minimum element from right binary search tree, then we will continuously go left so that we can find we continually go right so that we can find the we will continuously go left so that we can find minimum element. Okay, so while temp arrow left is not equal to null, we will update our temporary as temp arrow left. That's it. At this point we have got our minimum element in temporary. So what we'll do, we will update our root arrow value as temporary arrow value, temp arrow value, and then we will delete temp from right binary search tree. So root arrow right will be equal to delete node from root arrow right comma temp arrow value, and that's it. I think this should work. Okay, so let's see, will it work or not? It was giving an error, line number 33 and 32. It should be in curly braces. it's working. So let's submit it. It is accepted. So that's it for this video, guys. Thanks for watching. See you in next video.